And hello, everyone, and thank you for joining today's AIA presentation. And I want to thank Instone for being a great partner and facilitating us all getting together here. My name is Cliff Height. I'm with Fireplaces. I am Regional Sales Manager with our Distribution Division, covering Midwest, Mid-Atlantic, Northeast, and parts of Canada. Considering what's going on in the world, it's great that we can all keep connected with the architectural community and continue to the best of our ability. Business as normal. Our facilities, Isokern, is up and running, and we're taking the right precautions nationally to supply the building community while taking necessary precautions to keep our employees safe. I hope everyone else is being safe as well. All right, so today we're going to talk about Isokern fireplaces in modern construction. Earthcore Industries is the exclusive manufacturer of Isokern fireplaces in North America. We are a registered provider. Oh, let me go to the next slide. There we go. So we are the exclusive manufacturer of Isokern fireplaces in North America. We are a registered provider with the American Institute of Architects. And upon completion of the presentation, you'll receive your credits for today's presentation. All of our contact information is listed on this page. After the presentation, you're welcome to contact me directly in more specific terms about any projects that you may have. Our objectives today will be a general overview of different types, different applications, primarily wood burning or gas burning. We'll discuss masonry built fireplaces, metal box fireplaces, and modular refractory fireplaces. We'll discuss performance of the chimney and drafting performance, how to set up your fireplace to be the most functional and highest performing that it can be. We'll touch on some code compliance at the end of the presentation. A big part of what we do is making certain we follow all national, state, local business codes. So we'll touch on all this today. You know, before these presentations, I make it a point to look up what's the earliest documentation of man's use of fire. According to American Archaeology magazine, we've recorded the controlled use of fire by our ancestors going back 1.4 million years. Man has had a very long and intimate relationship with fire. Since we have been building dwellings, we've been using fire for cooking, to heat our spaces, and to provide light inside of our homes. In the modern world, fireplaces are primarily used for visual interest and aesthetics, but there are still a lot of functional features we can provide with light and heat in your project. It really is endless in relation to sizes, shapes, and the applications of how we can contain and enjoy an open flame in our homes, whether it be wood burning or through a gas burning fireplace. Burning wood is the most traditional use of fireplaces. Throughout most of the United States, almost every house was built with a traditional masonry fireplace. Up until around the 1990s, and in some places earlier than this, people started using gas fireplaces. But there are millions of scratch-built masonry wood-burning fireplaces all over the country. You know, a lot of people grew up in homes that had a traditional wood-burning fireplace, and the picture in this slide is indicative of how that fireplace could look. An open fireplace with fire brick that's ready to burn wood. These fireplaces, be it metal, traditional masonry, or a modular masonry fireplace, all have to meet code requirements tested in a specific standard to be code compliant in a residential or commercial application. As you notice, the second bullet point, these fireplaces are tested and listed to the safety of UL standards. This is true for a metal fireplace, true for a modular fireplace, but in traditional masonry fireplace, there's a uniform building code called the NFP 211, and this is the National Fire Protection Association 211. Among other things, they'll dictate the ratio of opening size, of the firebox to the chimney size, to the chimney flue, and dictates the types of materials that can be used to create the firebox and chimney systems. Class A will designate that a chimney flue is rated for solid fuels. Class A chimney can vent a wood-burning fireplace or gas fireplace. It's rated to withstand high temperatures. Anytime you use metal flue for a wood-burning fireplace, it'll always be a Class A metal flue. Chimneys can also be built with a refractory chimney system. Traditionally, the refractory system would be a clay flue liner surrounded by other masonry material. Or in a prefabricated system, in a modular application, you could have a refractory chimney system that is made from components that also use a UL standard. For any residential wood-burning fireplace, you can offset the chimney system to a maximum of 30 degrees, and you can only have one offset in that chimney system, or you'll be required to use a mechanical exhaust fan to guarantee draft. Gas-burning fireplaces, which have become the predominant application of fireplaces, especially in new construction projects across the US, come in a very wide range of sizes and styles. You can find something to meet any application, whether it be very modern or very traditional. Gas-burning fireplaces typically come in 3 venting styles. B-vent application designates that the venting is appropriate for gas-only venting, a lower temperature rating than a Class A venting, and is specifically engineered to vent a fireplace that is utilizing propane or natural gas as a source of the fuel, not wood. There are things that you can do with a Class B chimney system as far as offsets, the inside diameter of the chimney flue in relation to the firebox opening, that provide more freedom in the routing of the chimney flue. Class B always means that it is going to be a gas-burning chimney system, and the natural drafting Class B chimney is always going to terminate vertically above the roofline. The next option is a direct vent fireplace. A direct vent is a sealed glass front type fireplace that draws unconditioned air from the outside of the living space. It'll bring that oxygen into the firebox to aid the combustion of the fire, and then a chimney system exhausts the output of the gas logs outside the building envelope. For energy efficiency, you're not disturbing the conditioned air from inside the home, and everything is sealed up, so ideally no air inside is being used for the fireplace, and you have no energy loss through the fireplace because it has a sealed glass front. The very definition of a direct vent fireplace is that it is going to have a sealed glass front and not use air, the inside air, to help vent fireplace. The third option is a vent-free firebox. Vent-free is exactly what it sounds like. It's a fireplace that has no chimney. Rules for the vent-free fireplaces vary regionally throughout the US. Generally speaking, it's a popular code in most jurisdictions that you cannot put a vent-free firebox in bathrooms or bedrooms. Vent-free fireplaces have come a long way since they were first introduced to the market. They're considered a decorative gas appliance, and they have a lot of freedom in what the foundation is and what is going to be surrounding them. The burning system for all vent-free will have a maximum output of less than 40,000 BTUs. And to put that in perspective, the main burner for most residential gas ranges would have about 20,000 BTUs as the output. Vent-free burners will also have an ODS, or an oxygen depletion sensor. If there's not enough oxygen for the burner to operate safely, the burner will shut down. For many years, houses would have traditional site-built fireplaces, and as technology has improved and construction practices have evolved, more types and styles of fireplaces are being utilized than ever before. We'll look at this in greater detail in these next few slides. I think this is a neat picture of what a traditional masonry fireplace can look like. Masonry fireplaces are labor intensive, requiring a highly skilled and experienced mason. They're always built starting on the inside, working to the outside. They'd be lined with fire brick, then common brick, then typically concrete masonry units, and then a masonry veneer on the outside of that. That masonry veneer is often continued through portions of the house and above the roofline. Because of the giant mass of masonry material in a traditional masonry fireplace, it always needs a foundation all the way down to the footer. The scenario that I think about is a two-story home with a full basement. If there's a fireplace in the living room, that means from the basement, you need to have a full masonry superstructure to support that firebox and the chimney and the weight of all the brick and block and stone to carry that weight. And the masonry material has to continue through the second story living area, through the attic and above the roofline. Due to the nature of all the material and build process, it can take weeks, sometimes more than weeks, to build a traditional masonry fireplace. And you're very reliant on the skill of the masonry contractor to build a fireplace that is going to function properly. Traditional masonry fireplaces are always vented with a clay flue liner. Clay flue liners are typically rectangular in shape. They get mortared together, and the masonry surround is built around that. And if you follow good masonry practices, you should only build it so tall in one day, maybe 4 to 6 feet of vertical progress in a day. Additionally, many regions require that a smoke dome inspection is required before starting to build the flue liner and the chimney. These are some of the reasons that contribute to a long time on the job site. The cost of building a traditional masonry fireplace and the skill involved in having a contractor to come and build them are some of the reasons why they are not as popular as they were a few decades ago. There are some distinct advantages of a traditional masonry fireplace, and that is because they are rated for solid fuels. You could burn wood. You could also install a gas log system, so you have some freedom, and you know you are typically not going to overheat the masonry fireplace. You don't have this freedom with some other engineered systems. Another nice thing about traditional masonry fireplaces is all of that masonry construction and all of that mass of masonry, when the fireplace is in use, is actually heating up. So at the end of the usage of the fireplace, when the fire goes out, you still get radiant heat that comes out of the fireplace. However, since traditional masonry fireplaces are built individually on a job site with variables that can't really be measured, there are no UL standards for a traditional masonry fireplace. Interesting things and a long history of traditional masonry fireplaces in the US and Canada. My slide's not moving, there we go. The next type of fireplaces are metal boxes. I think the picture on this slide will be familiar to most people. The metal boxes are trying to imitate the aesthetics of a traditional masonry fireplace. Some type of faux. One advantage over masonry is that these are tested and listed and pre-engineered for that application. Metal boxes are very lightweight when compared to masonry materials, so you don't need a massive foundation to support the firebox. And the vast majority of the time, the firebox can be installed over a wooden subfloor without any other structural components needing to be added for either the firebox or the chimney flue. Metal boxes come in a wide range of styles and sizes. You could have a sealed glass front, like in the picture. Open metal boxes are available as well. Because they are UL listed, the pre-engineered package of what you buy and what is installed in the home at the time of construction can never change. The gas logs, the brick liner of any of the accessories all the way up to the chimney cap must be the manufacturer's authorized components installed per their installation manuals. If a homeowner needs to ever change or the house changes ownership and the aesthetics are different from what the homeowner would like, there's no options to make changes. There's no option to personalize the fireplace once it's installed. You just get what you get. The average metal fireplace has the lowest lifespan of the fireplace choices. And they could rust or the metal could be compromised in some way over time. If you think about structures that want to be built for a very long time, you have to consider that the components will require annual maintenance and there is a shelf life for your average metal box. Modular refractory fireplaces are really a hybrid between traditional masonry materials and a metal box. Modular simply means pieces go together on a job site. I very often describe isochron fireplaces as a masonry Lego kit that's assembled on a job site. Specifically with isochron, we import volcanic pumice from Iceland, of all places, and there is a reason that we utilize pumice from Iceland as our raw material. It is very lightweight, and it's also naturally refractive. It doesn't absorb heat, it reflects heat. We can do things with this material that you could never do in traditional masonry because of the weight, or with metal because metal conducts heat and does not reflect it. If you think about a big Lego system that gets assembled on a job site, that's what our modular fireplace system is. You reduce a lot of the costs when you compare to a traditional masonry system because you're eliminating a huge amount of highly skilled labor. Typically, a modular fireplace, including the masonry or metal chimney, can be installed in a day, and the fire brick can be installed on the second day. They are very quick, easy to install. They come from the manufacturing facility in a package that gets assembled on a job site according to an installation manual, and they are tested to UL standards. If UL listings are a requirement in your local jurisdiction, you can use this type of fireplace because the systems are pre-engineered, they can be replicated on a job site, and they come with an installation manual. There is a big variety of applications of modular refractory fireplaces, from gas to wood to very traditional to very modern and sleek. These are a hybrid of traditional masonry and UL listed metal fireplaces. In any of the solid fuel rated fireplaces, you can burn wood, but you could also install any type of gas burner system that meets the firebox enclosure size. Over time, the owner has the option to change from a gas to wood burning and vice versa. With a traditional masonry fireplace, we discussed the footer to support all the masonry material in that style of build. In the modular fireplace systems, due to the lightweight volcanic pumice aggregate, you do not need a giant foundation. You can actually install a wood-burning UL-listed masonry fireplace over a wooden subfloor. In our case, we use a firelight stand to accomplish this. We have firelight systems for wood-burning fireplace with up to 6-foot wide openings. You could have a giant wood-burning fireplace on any floor of the home without the massive footer to support the weight of the box, and then use metal chimney flue to vent the fireplace. Or if you don't have any weight restrictions, we have a 2-part masonry chimney system that is made from the same material as a firebox. You could take one firebox that is a static inside dimension, opening height, opening depth, and it can do a lot of different things. We could put these outside, we can put them inside, on front porches, multi-season rooms. We could use metal flue to vent them. We can use our masonry chimney system to vent them. They can burn wood, they can burn natural gas, they can burn propane. You have a lot of flexibility when you get into the world of modular fireplaces. We do not have the same limitations that you would have in traditional masonry or metal box fireplaces. Dan, I thought I'd take a quick break here and see if anybody has any questions.
You know, Cliff, you're covering everything great. There's no questions up right now, but the audio and the slides are looking really well. Thanks for taking the break, but we're good.
Perfect. Thanks so much. Every now and then I'm getting stuck moving the slide forward. There we go. How do I get that? This is. All right, so with any firebox, it's only as good as a chimney system that is going to go on top of it. We're going to spend some time talking about how to make sure that your fireplace functions properly and variables that can affect the chimney system. Think about your construction project as a system, and we're going to discuss managing the airflow. There are things like natural draft and mechanical venting systems that we'll talk about. We'll get into how tighter homes are affecting fireplace draft, placement of a chimney, wind loads as a factor, and get into topics that you can consider to make sure fireplaces are successfully incorporated into your plans. So here we have a slide showing the different chimney types that are available. So that first one in the middle is a traditional masonry chimney type, which you'll see there's the clay flue liner sections, which you can only build up to a certain height every day, surrounded by CMU units and then brick. To the left, you'll see Isokern's DM54 system. It's a two-part system with an outer casing and an inner liner. All components are tongue and groove. They're all about a foot tall, so it goes together easily. It's easy to do takeoffs. They're lightweight, and it is the only zero clearance chimney system of its kind. So you can frame right up to it if you had to, or you could put thin veneer on it if you'd like, or if you want to keep in the theme of a traditional masonry build and you want to have full brick or full bed veneer coming out of your roof, you can utilize that brick ledge, which is packed with pencil thin rebar and will hold up to 9,400 pounds. There's more instructions in the manual on how to put those together. And the alternative is, if you're building modular refractory fireplaces over a combustible subfloor, you could use, in the bottom right, you'll see Class A. That's Isokern EcoSteel Class A flue for wood burning fireplaces. And then in the middle, you'll see B-Vent, which is for gas only burning. And there's a lot more flexibility with B-Vent as far as smaller sizes in relation to firebox openings. And they can actually have a 45-degree angle because it's gas only, where your Class A would only have a 30-degree angle on offsets. Natural draft is gravity draft. Warm air always rises. So whether it's a wood fire or a gas log system, if you heat the inside of a firebox and the smoke dome and the first few feet of chimney flue to be warmer than the surrounding ambient air temperature, that exhaust from the fire will go up and out the chimney. This is the ideal scenario, and for many years this was easy to achieve. We'll talk about why that has become harder in today's new construction in the next couple slides. There are two main factors that affect the amount of draft produced by a chimney. Number one is just heat. The hotter the fire is, the better it will draft, and the stronger it will draft. The second is the proper air pressure balance inside the structure. Most fireplaces fall into the category that you are relying on natural draft to exhaust the output of the wood fire or gas logs inside the fireplace. One of the major categories that makes creating that draft more difficult these days is the highly insulated nature of new construction now. One of the things driving this is energy efficiency, which is a very good thing for keeping utility bills down and making sure our utility providers are operating as efficiently as possible. However, tightly sealed house walls do not allow air to come back into the house. An analogy that I often hear is that you are living inside of a Ziploc bag. While air may come into the structure, very little air gets out. Unless your HVAC system has been engineered to provide a specific amount of makeup air, houses can be so tight that you cannot aid the combustion of a wood-burning fireplace because literally there's not enough air in the home to facilitate the performance of the flame and draft. One of the ways to know a house is too tight when there's an underperforming fireplace is to crack a window or door to get the proper air to the fireplace. Outside combustion air at the fireplace is one way to overcome this. Fire burns oxygen, and when you place that outside combustion air in the correct location on the side wall of the fireplace, never the back wall, always on the side wall, you provide air where it is needed. Another advantage is outside air on the firebox wall creates less disturbance to the rest of the air in the structure. Another factor outside of the home to consider is wind loading. This is an effect on the internal house pressures caused by external wind. If the home is in a windy area where there are predominant winds off of an ocean or a lake or a mountain range, this should be taken into consideration when planning the location of the fireplace. When wind hits a building, it creates high pressure on the windward side and negative pressure on the leeward side. Openings of windows and doors on the windward side will help pressurize the house, helping to promote draft. Alternatively, opening windows or doors on the leeward side may increase the likelihood for negative pressure, which could cause spillage or a backdraft situation. So another factor to look at, the stack effect, has to do with the structure's pressure changes from floor to floor. Essentially, as warm air rises in the home, it could have the tendency to pull air from lower levels. If we look at the image in this slide, and you notice the bad images on the left, we have a fireplace on a lower level on an exterior wall, and let's assume that that chimney is not well insulated and providing a cold flue condition. Now, I came across a situation once with a basement fireplace, that's as low as you can get in the house, in the basement, on an exterior wall, in a very tight home with super high R values. This home was starved for air and was pulling air down the flue into the basement when the fireplace was not in use. Unfortunately, in this particular house, the location of the fireplace had the correct ingredients for a stack effect recipe. A better choice for the home in the picture would be a centrally located fireplace, as the chimney would be better insulated. The placement of the fireplace in the home can affect performance of the fireplace. In addition to overly insulated homes, probably the second hardest thing to overcome is competing with interior mechanical devices. The ones that probably are the hardest to overcome are the kitchen exhaust hoods and bathroom exhaust fans that literally suck air out of the structure. When those are on, they are mechanically competing against a natural gravity draft fireplace system. Any penetration in the roof of a home can create a way for air to leave the house. The number of penetrations in the roof deck, the number of mechanical appliances stealing air from the structure are all going to compete with the fireplace. Things like clothes dryers, kitchen fans, bathroom fans, attic fans, central vacuum systems can all depressurize the home by removing large volumes of air from the house. This creates negative pressure in the area of the fireplace and will provide the opportunity to challenge that fireplace to draft naturally and perform as it should. So one way to overcome this, when we find ourselves in a situation, for instance, Let's think of a commercial application with a big wood-burning fireplace in a dynamic restaurant environment. The restaurant could have large kitchen hoods with exhaust fans pulling large volumes of air, and there are doors at the entrance that are constantly opening and closing. Or if we get away from our stock single-sided fireplaces and create custom fireplaces outside of the UL standards that we've tested and listed, we would look to mechanical venting solution to guarantee the draft of the fireplace. Fans are installed at the top of the chimney system, and they would function in a very similar manner to a kitchen hood or bathroom exhaust fan, creating draft by pulling air out of the chimney system. There is a mathematical equation that has to be followed to ensure that the fireplace size, the fireplace type, the fuel type, the diameter of the venting, and the length of the run are all considered to ensure that the proper fan size, we have the right fan size to the job in order to guarantee that the fireplace will perform as intended. Once you accomplish this, you now have an engineered chimney system that will guarantee the draft of that fireplace. You can do this with gas or wood fireplaces, and we can be a lot of help in designing these systems for you. Dan, I thought I'd take a break again and just see if there's any questions out there.
It looks like you're covering everything thoroughly, Cliff. So, please continue. It's great information.
Perfect. Thank you. So this is our last slide. We sell a lot of product throughout North America. It's challenging to make a blanket statement about code compliance as rules vary around the country depending where you are. One of the things that you can think about when it comes to code compliance is consider starting with UL tested and listed products that have an installation manual. If you have an installation manual that you can hand to code compliance officers, this can make life very easy. The manufacturer has done all the engineering for you, and they are not expecting you as a design professional to have all the nuts and bolts of the fireplace figured out on your own. We have a lot of resources to help you with this. There's a lot of documentation on our website. Among other things, you'll find spec sheets, installation manuals, and a wide array of drawings that you could use as inspiration for your next project.